Hello everyone. In this video we are going to discuss the properties of cross power density spectrum. So the first property is Sxy of omega equals to Syx of minus omega equals to S conjugate of Yx of omega. To prove this statement we need to consider the equation of cross power density spectrum. This is the equation. Sxy of omega equals to integral minus infinity to infinity Rxy of tau into e to the power of minus j omega tau into d tau. So let us consider the tau equals to minus tau. Sxy of omega equals to integral minus infinity to infinity Rxy of minus tau into e to the power of minus j omega tau into d tau. Since Rxy of minus tau equals to Ryx of tau, this is known as symmetric property. Sxy of omega equals to integral minus infinity to infinity Ryx of tau into e to the power of minus j omega tau into d tau. Therefore, Sxy of omega equals to Syx of minus omega, that is equals to S conjugate of Yx of omega, hence proved. So coming to the second property, Sxy of omega equals to 0 and Syx of omega equals to 0 if x of t and y of t are orthogonal. Proof. From the properties of cross correlation function, we know that the random process x of t and y of t are said to be orthogonal if and only if their cross correlation function is 0. Mathematically, Rxy of tau equals to Ryx of tau equals to 0. Consider this as equation 1. We know that Sxy of omega equals to integral minus infinity to infinity Rxy of tau into e to the power of minus j omega tau into d tau. From equation 1, we know that Rxy of tau equals to 0. So, Sxy of omega equals to integral minus infinity to infinity 0 into e to the power of minus j omega tau into d tau. Therefore, Sxy of omega equals to 0. Similarly, Syx of omega equals to integral minus infinity to infinity Rxy of tau into e to the power of minus j omega tau into d tau. So, from equation 1 we know that Rxy of tau equals to 0. So, Syx of omega equals to 0, hence proved. So, coming to the third property, if x of t and y of t are uncorrelated and have constant mean values x bar and y bar, then Sxy of omega equals to 2 pi x bar y bar and dou omega. Proof. From the CPDS is Sxy of omega equals to integral minus infinity to infinity Rxy of tau into e to the power of minus j omega tau into d tau. Rxy of tau is equals to integral minus infinity to infinity e of x of t into y of t minus tau into e to the power of minus j omega tau into d tau. Since x of t and y of t are uncorrelated, here uncorrelated means both are independent of each other. So, e of x of t into y of t plus tau. So, by elaborating this equation, it can be written as e of x of t into e of y of t plus tau. Therefore, Sxy of omega equals to integral minus infinity to infinity e of x of t into e of y of t plus tau into e to the power of minus j omega tau into d tau. That is equals to integral minus infinity to infinity x bar and y bar into e to the power of minus j omega tau into d tau. So, by taking this x bar and y bar outside, integral minus infinity to infinity e to the power of j omega tau into d tau. So, here integral e to the power j omega tau into d tau is nothing but 2 pi del omega. So, therefore, Sxy of omega equals to x bar y bar 2 pi dou omega, hence proved. Thank you.